What's up everyone, and thank you for choosing to learn with LAM. Today we're going to be learning about the basics of ice tables, how to use them, and what they're used for. Now, this is a bit of a longer video, but ice tables are kind of like the stoichiometry of grade 12, where if we can set them up correctly, it can really simplify the whole process. So we want to make sure that we get this down pat. First things first, what does ice even mean? Well, I stands for initial concentrations of reactants and products, C is for change in concentrations of reactants and products, and E is for equilibrium concentrations of reactants and products. Now, let's do a couple practice problems so we can see this in action. Determine the KEQ for the decomposition of HI gas to form hydrogen gas and iodine gas if 0.200 moles of HI gas in a 2.00 liter flask decomposes and, once equilibrium is reached, there is 0.156 moles of HI gas remaining. So for this first type of question, we're using ice tables to determine KEQ. Just a reminder that KEQ is calculated using the equilibrium concentrations of products over reactants. So that's what we're aiming to find. So to set up our ice table, we're going to write out the reaction and then we're going to balance it. Ice down the side. Now, notice that we're always talking about concentration when it comes to ice tables, so a lot of the time we're going to need to convert from moles. In this case, we're given 0.200 moles of HI gas in a 2.00 liter flask, so we're going to use the molar concentration equation to convert that. 0.200 moles divided by 2.00 liters gives us 0.100 moles per liter, and we'll put that down as our initial concentration of HI gas. Now, considering that the reaction hasn't started yet and there's no mention in the question of any hydrogen gas or iodine gas at the beginning of the experiment, we can go ahead and assume that there's no hydrogen gas or iodine gas at all. But just a heads up, these columns are not always zero, and we'll do examples of that in a future video. Now for the change. I know that my reactant concentration is going to start decreasing as the reaction progresses, so this is going to be a negative change. And because HI gas has a coefficient of 2, we're going to put down a 2 here. And lastly, we're going to put an X here to represent the amount of change that's going to occur because we don't actually know what that change is going to be yet. For hydrogen gas and iodine gas, change is going to be positive because they're products. And because their coefficients are both 1, we'll just put the X here. Notice that HI gas changes at twice the rate of hydrogen gas and iodine gas, which makes sense considering the balanced chemical equation. And now for E, I'm going to combine my I and C rows, which gives me 0.100 moles per liter minus 2x, X, and X. Notice that I do have some extra information when it comes to equilibrium. There's 0.156 moles of HI gas remaining. Now again, we're interested in concentration, so let's just divide that by 2.00 liters to give us 0.078 moles per liter. And notice that both of these terms represent the equilibrium concentration of HI gas, meaning they must be equal. So now I've got a nice equation to help me solve for X, which will give me all the equilibrium concentrations I need. So let's just clean this up a bit here, make some room. And now I've got 0.100 molar minus 2x equals 0.078 molar. Subtract 0.100 molar from both sides, and I get negative 2x equals negative 0.022 molar, and I'll divide both sides by negative 2, which means X equals 0.011 moles per liter, and I can substitute that number here and here. And now to solve for KEQ, it's the equilibrium concentrations of my products, hydrogen gas and iodine gas, over my reactant, HI gas, squared because of the coefficient. So let's substitute in our values, and that gives us 0.019888, which will round to 0.020. So that's what solving for KEQ looks like, but that's not the only type of question that ice tables are good for. Determine the equilibrium concentration of each substance if 1.00 moles of carbon monoxide gas is mixed with 1.00 moles of water vapor in a 5.00 liter container to produce hydrogen gas and carbon dioxide gas. The KEQ of this reaction is 0.83. So, notice this time we already have KEQ and we're looking for the concentration of each substance at equilibrium. No problem. We'll set up our ice tables just like we did before. Balanced chemical equation, ice down the side, and again, we want concentration, so if we divide these 1.00 moles by 5.00 liters, we get 0.200 moles per liter each. Again, no mention of hydrogen gas and carbon dioxide gas in the beginning, so we assume they're 0. Change is again minus x for reactants and plus x for products, just x because all the coefficients are 1, and we'll put them together for equilibrium. So 0.200 minus x, 0.200 minus x again, x, and x. So these are the values that we're trying to solve for. Again, as soon as I have x, we're just a substitution away from the answer, so let's set up our KEQ equation, products over reactants as usual, and we'll substitute in all of the information we have. So 0.83 equals x times x divided by 0.200 minus x times 0.200 minus x, which we can simplify to x squared over 0.200 minus x squared. Now, if I square root both sides, I get 0.911 equals x over 0.200 minus x. So I'll multiply both sides by the denominator, which gives me 0.1822 minus 0.911x equals x. I'll add 0.911x to both sides to collect like terms. We're running a bit tight on space here, so let's just move over here. Divide both sides by 1.911, and that gives me x equals 0.09534. Great. Now I can take this x value and substitute it back into the equilibrium row, giving me 0.10466 for carbon monoxide, which I'll round to 0.105 moles per liter, 0.150 moles per liter for water vapor also, 0.0953 moles per liter for hydrogen gas, and the same thing for carbon dioxide gas. And just to do a quick check of our answer, notice that because KEQ is just a smidge less than 1, it makes sense that our reactant values are just a little bit higher than our product values. And that's that. As always, if you have any questions or if you have any topics you'd like me to cover, just leave them in the comments. Good job, everyone. If you find that you need a little extra help, please feel free to check out my other videos for tips and tricks on how to succeed in school. And as always, thanks for learning with LAM.